Okay, welcome everyone. Thanks for jumping in. I know it's the last session of the day, which is always a tough one to stay awake during. Hopefully the content's pretty interesting though, and it's related to something called command line spoofing. And really the question is, can we trust the process creation logs in Windows? And the short answer is not really, but sometimes you can, sometimes you can't, and it is difficult to determine under which circumstances logs are true and which ones have been tampered with. My name's Tristan Bennett. I work at a company called Seamless Intelligence, which I actually co-founded about 8 years ago, and we operate out of Perth, Western Australia. So I flew across on Monday. It was 44 degrees in Perth when I flew across, Celsius, and then hit Oslo, and it was a bit chillier. But yeah, it's really nice here. We run a SOC. We do one thing. We do security operations, and we attempted to do one thing and do it really well. And so I'm head up the research team, and so we're looking for new attacker techniques, new tools to play with, GitHub repositories that have code for us to go and play with those sorts of things. Throughout all of this testing, our main goal is to be able to understand and then detect whatever we have looked at, new techniques, and we've actually had bug bounties from CrowdStrike and from Microsoft for finding various things that get around either their tools or break stuff in Windows that we've been assigned bug bounties for. And we've got 3 attributions into the MITRE ATT&CK framework, which is pretty cool, and it's a really good sort of framework to assign things to within the sort of techniques that attackers use. What we're talking about though is actually a GitHub repository that's probably 4 years old now. This technique's not brand new, which is part of the reason why it's so disappointing with the results we'll get at the end. And it came across because it's a tool that can make our lives when we're looking at logs very difficult, and you'll see why. So we started to look into it, we compiled it, we ran it. It does what it says it does, and it makes it very, very difficult for our SOC analysts to understand, if it's used, exactly the commands that are run. So what it is a novel technique to go and alter the logs in Windows without having any sort of special permissions. And what it leads to, and what it can lead to, is an incorrect assessment on what has happened in an environment, because you don't actually know what an attacker has run, because you can't see the actual command line that was truly run. You only see the portion the attacker wants you to see, not what was run. And so the really difficult thing for us is when this gets paired up with brand new techniques and tools that hide this, it's very difficult to work back to understand exactly what happened. What it's not though, is it's not any sort of privilege escalation technique. If you need a command to be run that requires local admin privilege, you'll need that privilege within your session. You don't just magically get it through this tool. It doesn't hide all types of commands, which is a benefit for us, and it doesn't stop software like EDR, like your antivirus, from looking at what the command is trying to do, or if it's interacting with memory or other processes, it doesn't stop EDR seeing that. So a process creation, very simple one at the top, which is just us telling PowerShell to run this base64 encoded command. And all it is a who am I all, which lists out my domain user account, lists all of my groups, and it lists the privileges in the current session. And attackers do run this, or their scripts do run it at the start, because we can get all of our domain group memberships. We can see I'm a domain admin, but we can also see that I'm running in a low privilege or a normal user mandatory label, which medium there means I'm just a normal user. These privileges are quite interesting to an attacker as well. There's a couple of notorious ones within Windows that allow you quite a high level of privilege regardless of your groups that you're a member of. And so these commands are quite common. They're also quite common to be packaged up, just running with PowerShell as an encoded command, because it's that level of obfuscation, and every layer they add, they seem to think helps and helps and helps, when that's kind of suspect on its own, a normal user running an encoded command. Generally, when people start an argument with the dictionary definition of something, I sort of turn off. If that's what you're relying on, then you don't have much else. But it's really important in this case, because I was under the assumption before all of this that this is what Windows runs. This log that I get, this process creation log, is what Windows runs. That's simply not the case. It is just the process being created. It doesn't even need to start. There's a structure which we'll go into which says I've created a process. That's what gets logged at Windows. And so it being a process creation is actually quite important. There is no logs in Windows for what runs as far as command line running programs. This here is the XML for our command process creation log. Up the top here in this is timestamps and other important information for us, but it's stuff I've just carved out of all the examples. And what we're left with is the good stuff here where we can see our command line. We can see the parent process and those sorts of things in there. So we can often follow the stream of what's happened in a set of commands by looking just at a process creation log which has all of this, including the user. It also shows here the mandatory label, which Windows, Microsoft do not have any sort of consistency across any of their products. You'll see here it's a numeric. In Sysmon, see later on, it says high, medium, or system, which is far, far better. But the command line is really cool. So when we see something that's executed via command that then goes and calls PowerShell or the base64 command or whatever arguments there, we can go and pull those out. And we can do things like just base64 decode this really quickly to go and see what's happening. If you're using something like Sentinel or Defender, which has KQL, or something like Splunk, you can do a lot more manipulation to your logs when you're looking at them. And so this KQL here actually grabs this base64 portion of the command line, decodes it, and then shows us that in one simple search. So this for our analysts is pretty gold because we can just show them immediately what the base64 decoded command is within PowerShell and show it to them in one simple search. This is a Sysmon log. So evid1 in Sysmon land is our process creation, and it's almost identical to a process creation log natively in Windows, which the other ones were. We just get a heap more information, like we get the hash of the executable that was run, and here we get integrity level, and we get the human readable. So this was run as a medium, which is a normal user, not admin. We also get things like original file name, which descriptions and products which can often have the author's name. So Mimikatz, which is a credential stealing tool that's been around for the best part of a decade. We so often see attackers will change the exe name, but the original file name stays the same, and so does all the metadata on the descriptions. And so those can still be used outside of this technique to help detect things. This is the process creation, which is a device process event. So if your organizations are running Defender XDR, that actually produces logs as well. These go up into the advanced hunting. You can look through them there with KQL, and you can put those into Sentinel, and they look like this. So slightly different. They have a lot more information about the event, such as if I RDP'd onto a server and then ran the command, it would have my original workstation IP. And so you could track that back in one log, which is really cool. But unfortunately, all of them suffer from this technique. And so ultimately, this process command line can't be trusted when it's spoofed in the way that we'll show. They're good for lots of things. So within Windows, they're our primary log for detections. Authentication stuff is all well and good for brute forcing and some initial access, but really an authentication log doesn't have much context on it within a Windows domain environment. You succeed, you pass, you're generally still on the internal network, you may be from a VPN, but it doesn't tell us a whole lot. Whereas when you go and start running things and performing actions, that's where we start to see PowerShell command logs. We start to see what someone is doing, and it's a lot. The detections there are much higher confidence than simply being able to log in to a server. Now, brute forcing and password sprays and those things, they're completely different. They're great indicators, but one user logging into a server as a one-off is not the greatest of indicators. Tool called Rubius. This is it interacts with Kerberos. It's the Swiss Army knife of abusing Kerberos in Windows. And what we often find is attackers will go and change executable names because that's easy. They may change metadata and recompile. But we've just seen time and time again that if there's a releases page on GitHub, they'll grab that exe and run it. They may even pull it down with PowerShell directly from GitHub. And then we have this command line argument, Kerberoast, which will go off, and Kerberoasting is a pretty cool attack that's still relevant. Once again, it's probably the best part of a decade old, where if an account in a domain has a service principal name and we're a domain user, we can basically get the password hash. It's as simple as that. If the password is quite bad, brute force that and you've got the hash for a service account or something like that. So we see Kerberoasting used a lot. But this is where it becomes really useful. The amount of information that generally attack tools allow you to put onto the command line in the form of parameters is huge. And so this is still Rubius, I just changed it to Nobius. So if we had a detection just looking for Rubius on the command line, which we do as insurance, because we'd look like idiots if we missed it, it won't fire. So what we do is we test and we go and say, this is going to abuse a silver ticket in Kerberos, and it's going to give me, hopefully when I run it, admin access using the built-in administrator account on a server. So that user of TBOS has a certain level of privileges. We run this command and we use this flag here, PTT, to pass a token into the current session. We can then use it. So all of these are really good indicators because they're not command line parameters that are normal and seen a lot from normal users and even admins. And then what you can do in Sentinel is something like, all right, well, I'll list out Silver, cred user, Kerb encryption type, and then I'll say, if I see 3 of them on a command line, let me know about it at a quite high priority. So we can get a lot of information about attack tools from what's on the command line. The other thing we have going for us is there's really only one way to execute PowerShell remotely using PS remoting, but there are many ways to execute things via command. So very often we'll see PowerShell packaged up and run via command, which means we get all of these logs, or not if we use command line spoofing. So the process creation itself starts with the process environment block. I wish everything in computers actually looked like all of this, but the process environment block, and being a dev conference, this might look better. That's what it looks like. So this is the structure that Windows builds whenever you go and execute anything in command. You open WinCalc, it will create one of these. The important things to note, and it's really only the first one, the rest spawn off that, is that it's a user mode structure. So the user that executes the process can then write those memory locations. There's no restrictions on that. Once again, it doesn't give you any privesk, but it means any user on a Windows system can do this and play with security logs basically, which previous to this technique were only accessible if you had local admin. The memory locations can be overwritten directly, and the contents are initialized by the NT create user process. So it's all in userland. There's no kernel, there's no nothing there. It's all in userland. And what it boils down to, this is the source code for the original command line spoofer, is that we will package up a malicious command. For that one, it's a PowerShell Empire beacon. And that's all we need to get a C2 link back to our command and control server to then go and execute whatever we want in that user context. So that's all it is really. And then what we do is we have our spoofed command, and you'll notice here, we just take the malicious command's length, and we just pad it with spaces. So this spoof command must be shorter initially than your malicious command, and we're just going to pad it out. The reason that it gets padded is within that process environment block, when we set the memory for it, we can't then change that. Whatever we override it with has to be exactly the same size, which is why we need to do this padding, which I thought was going to be an awesome detection avenue, and it turned out it wasn't. So then in Windows, we can create processes suspended. Now, I don't know why, and I don't know how prevalent this is because it's not logged and I can't tell, but I don't know why this would be used over suspending it within code. This is telling Windows, start my process, but don't start it, just create it. And so I just don't know the legitimate use for doing it at the OS level versus doing it within code. There must be a reason, probably being Microsoft, backwards compatibility, legacy, something. But it is there. So this gets created suspended. And we'll see here what it looks like when we run. I added a few breakpoints in the code just to see if I could see in Windows any logs that would allow me to see the malicious command. And there wasn't for for many of these examples. So that was it running the whoami. We can hide that PowerShell. All of the demos are really simple things, but you can hide that PowerShell so the user would never see it and all that sort of stuff. And so what we can see here is that's the spoofed command. All the spaces are there, and it gets added into the process environment block or process environment block. And then most of the code in command line spoofer is just looking for memory addresses. So we get the process PID, we go and get its PEB, we go and find within the PEB where the command line is specified, the memory location, and then we go and overwrite our new command, and then we say resume thread. And so what happens is, if we look at the execution flow, we have process created and it's suspended with the spoofed command. We then read the PEB here, and we find the command line part of the PEB. We then write the memory directly, and we can see here we override it with the malicious command and just pop that into the PEB. And then we just call resume thread. And that actually executes what's in the PEB, because the process doesn't even start here, it only gets created. So from a logging point of view, where I would like it logged is probably here. Where Windows logs it is here. And this is where the problem lies. It logs the spoofed command with all the padded spaces or whatever character you want here, but then we change it before it actually executes it, and we don't get a log there, we don't get a log there, and we don't get a log there. There's nothing. And so really Windows can log what's in the PEB, what's in the PEB there in that structure, but the process memory looks completely different when we execute it, but it logs that one. Whoops. It logs that one and not the bottom one. And so that's the whole technique summed up, that's what it does. And so it's pretty cool because any user can do it. And as we'll see, there are some commands in Windows that are perfect for using this technique, and there are some that are terrible. And so we're hoping the attackers don't really understand which ones are good and bad. They think it will hide everything. So when we go and tell PowerShell to run a whoami, it's very simple. We get thousands of lines in Process Monitor, which is another sysinternals tool. And we can see here when I've highlighted it, all the spaces are there. They're just not really visible unless you know what you're looking for, or they pad it out with a different character. And we can see here that further down here, PowerShell has then gone and created the whoami process with the whoami all out there. And so this is an example of a composite command which we'll go into, but composite commands are detectable because we're jumping through too many hoops, because we're telling PowerShell to create another process and that one hasn't been spoofed, and so we get the log there. But parent process-wise, we never see that that was initially executed via an encoded string forced into PowerShell. So I thought, this is easy. I will just look for, let's say, 10 trailing spaces, and at least there's a thread to pull on. It's not the greatest detection in the world, but the vast majority that catch attackers and pen testers aren't the best detections in the world. So I thought, yep, sweet, easy. We can see here we get parent, we get no other real metadata. So this was all I really had to work on. Or we could wait and hope that they do a composite command where we can see PowerShell now calling something else, and we would have a detection for that. This isn't a great option. It's still okay. There's still all of these detections for weird command lines out of PowerShell, but as we'll see, if we use certain tools, then we wouldn't get any detections. So I thought, yep, the spaces, this is how I'll get them. That's how it comes in the XML data. So I initially thought Windows was truncating the trailing spaces to save space or something like that from the 80s where every byte counted. But then I actually Googled it, looks like, and I haven't delved into XML standards. If anyone's an XML guru, let me know. I'm pretty sure it's just an XML thing where it just kills off the trailing spaces, because why would they be important? This is probably the only case where they are important, and it's taken away. And almost all monitoring platforms from Windows are going to take the XML log out because it's the easiest to process. So then we began looking at what other tools might be using it, and this is where, because it's a 4-year-old repository, this is why it came back on our radar. This one, multi-dump, came up. We love when researchers or attackers or pen testers release code to dump LSAS and things that are quite old but still really, really useful. You can get away with them. And something like a CrowdStrike, Defender, Palo Alto Cortex are going to pretty much kill any attempt to dump LSAS memory really, really quickly. And so we love it when it will dump it discreetly without triggering Defender alert. It's almost never the case. What we find is these guys will test with the home version, not the pro version, and they are named the same, and they couldn't be more dissimilar. The enterprise version has so much more to it. So we ran all of this and it didn't really work. But what piqued our interest was looking at the source code, we saw that it created the thread in a suspended state. And we're like, we've seen this before. No window either on this one. And then as we're looking further, we see dummy arguments that are going to be passed in before it does the real stuff. And so what our fear was, being a 4-year-old technique that most EDR didn't get, as she'll say, and Microsoft won't fix, was that it would become prevalent. Our bigger fear is that they coded in to do every command dynamically with this technique. So right now, I compile executables and run one thing at a time, because I'm just looking at it and researching. But I think to weaponize this to the next level, people will either use PowerShell or they'll actually dynamically generate their commands into this technique every time. So other tools using it, they're using it in this somewhat static way. I'm going to run one command, but I'm going to spoof this one here. And the big problem with this is, apologies for the size, but this is what Defender looks like. So you get a nice process tree, but you only get this when you get a detection for something. And as you'll see on the second run through, Defender didn't detect anything, so we never got this. But you'll also see here, if we go back one, our dummy command is saying, and it's all just trash, it's not real, it doesn't work, it's not a real command, but it looks good enough. So we're going to optimize startup, and who doesn't want an optimized startup? An optimized control panel. None of it exists, but here it is in the Defender log. And this was the trigger for us to raise this to Microsoft when the security products within their ecosystem excuse me, were vulnerable to this technique and giving wrong information in a detection. So it's all too easy then for an analyst or someone who's potentially looking at too many of these, because Defender's pretty false positive heavy, as are most EDRs, to go, oh, okay, no, that looks fine, or were fault, the Windows error reporting process in Windows will dump LSAS if a server crashes in a certain way, and we have a lot of alerts for were fault dumping LSAS, so that's what I would choose to spoof as. And so it gets run here with its dummy command. And what it's hiding is a really common technique to use this built-in DLL to create a mini dump of the LSAS process. What Defender reports it did is here, and all the logging reports this spoofed command here, which can send an analyst down a rabbit hole, or can lead to someone triaging that out as a false positive. It's just Defender again. It's unknown sign. Like, a lot of it just doesn't add up to being something of a critical severity. And Defender does throw out a fair few low and mediums throughout our customer base. So then we went on to do some more testing to see exactly which commands we couldn't see and which ones we could. And so we've got our composite commands. These are where command to PowerShell to do something else. We've got PowerShell, where it will just be PowerShell using commandlets to run a script just in line, so it will never leave PowerShell. And then we have built-in tools to Windows, where command just calls a tool to do something and then doesn't call PowerShell or anything else like that. So then what we decided to do as well, just to test our analysts, is put something that was legitimate. So I've got the advantage, I know attackers can't necessarily do this, but these are the top command lines for my environment of all of my Windows workstations. And so if I was going to choose one, it's probably going to be conhost, which gets generated once every 5 seconds or something. But we chose something down here, and in fact, I think for the demo, I even made something up. But an attacker can just go and get common service command line arguments, put those in, or make something up. I don't think it's going to make a real big difference unless it's one of these exactly, which I doubt they're going to match. And so a composite command, we have, once again, that's just our who am I in our base 64 encoding. And I just did some Teams update, something that you'd be like, yeah, Teams is updating again, even though it never updates through PowerShell. And then we just pad it with spaces. You can pad with any character. And one thing to note is your malicious and spoof commands Sorry. Your malicious and spoof commands have to, right now, with the proof of concept code, have to have the same process name, because if you change the command line arguments without changing the process, you won't change the process name, it will bug out. But one of the people we work with who was a student, which I'll go through later, is actually looking to be able to change the process completely, which if it works, so he's coding it in C, if it works will be even more dangerous, because now we won't even necessarily know what they use. So right now, if we use PowerShell, we match it up, and I know they've probably used PowerShell, I don't know exactly what it is, but with his new code, we're going to be able to change the process name as well as the command line. That's just another layer of annoyance. So for this one, as we discussed before, because it jumps between and it needs to create a new process at the very end, which isn't obfuscated or spoofed, we get a command line logging detection. We can do it there. We can also do it in PowerShell module logging, but we still don't get that initial process creation with our base 64 string. Now command line, with all the logging as well, this is where it gets really fun. So command line logging, as we've been looking at, has so much detail if it's turned on. If it's in a default state, that's what it looks like. So it's not on by default, and this is Microsoft's wording. Basically, if you haven't turned it on, you won't get anything, and the default to this day is not configured. So there are still organizations out there that have process creation logging on without the command line logging component because it's two settings. And so without it, we often come in, and as soon as we search for a 4688, or well, not an even one, but a 4688, if we don't see command line logging, we've got a visibility gap, and we need to turn that on pretty quickly. I can't believe it's still not on by default. PowerShell commands. These are where we're going to use commandlets. So for this example, we're going to add an exclusion for exes, for all exes on the system. And these MP preference type commandlets are all related to interacting with Windows Defender. Depending on setup, they may not work. But what we found with ransomware gang scripts, so they'll try all this even if Defender's not there. They don't care, and they don't have time to look at a system and understand exactly the privileges, exactly the EDR. They'll run their script that tries to stop CrowdStrike, Cylance, Carbon Black, and they'll do it all in sequence. And you go through and you look at the logs, and they're all there in sequence. Stop this server, stop this, stop this, stop this, stop this. Because ultimately, if they get detected, probably wasn't a place they could progress any further. And if their script runs without anyone knowing, they're probably a good target. And so we do see this all the time on environments without Defender, that you'll have set MP pref and try and disable real-time monitoring, and you'll have add exclusions and folders and things like that. And so once again, just spoof the Teams update type command, and this is what we get. We now get the spoofed command only coming off our initial executable, and we don't see anything else, because PowerShell never jumps out to create another process that does everything within PowerShell. So we can't detect the use of these commandlets through process creation or command line logging at all. We can with PowerShell module logging, and what PowerShell module logging allows us to do, this is an 800. There are a few different ways to log in PowerShell. There is module logging, which produces an 800. There is script block logging, which produces massive, enormous logs. But these ones are a bit better. But the really cool thing with the 800s is, because PowerShell is a scripting language, it actually will show you exactly what was executed at the end of the chain. So if you run, and I'll show one later, but if you run an encoded command, we'll get the decoded command in the logs as well. Because that's what PowerShell runs. It decodes it before running it. And so you can see here within the 800 in the module logging, we get PowerShell add MP pref exclusion. Cool, so we can detect it. The problem is, it's not on by default. And it's not even part of Windows Security logging. It's not part of Sysmon, and you don't get it with device logs. It's a specific set of PowerShell logging, which isn't available on PowerShell Core. So we've gone from PowerShell having no logging to PowerShell having some amazing logging, back to where Core's deployed, PowerShell having no logging again. And so we were relying on PowerShell quite heavily for lots of things, and a lot of attack tools now have just gone to .NET. So yeah, even harder to detect. But PowerShell's not there by default. And as I said, some of these encoded commands can be really large, and it's completely understandable why people use it to get around syntax errors and things like that, and it just makes it really nice and easy to use. But this command here, we would have to grab it, put it through base64 decoder, all that sort of stuff to understand what it was. But in an 800, it decodes it because that's what it's going to run. So this is me. I stripped out the Kerber roasting module from the Empire framework, cut it down to the lines I needed, and I can now run this attack against any account that I know has an SPN, and I don't trigger any of the current EDRs or Defender for Identity or anything like that. Because we're very clear in which ticket we want, it doesn't produce any detections. But we can see the full PowerShell there if we've got module logging turned on. Not default though. And you need to specify the modules. So we star the modules and just say log everything, which fortunately is valid. So then we have our built-in tools, and these are things like the SH for manipulating the Windows firewall. And there's a heap of other ones that I've got in a little table in the end. But so for this one, we're going to add a firewall rule inbound on port 8338. But really for RDP, it would be 3389. Once again, we'll do a bit of a longer padded out spoof command, and once again you'll see I've had to match the X's up, but I'm hoping to get around this limitation. So you'd know someone using the SH, you wouldn't know what they did. But that's if you even discover this and track back as well, and that's the other thing. With using these built-in commands, you don't see the final result to get a detection anyway. And so all we ever see here is Teams update, register, embedding, blah, blah, blah. Nothing logs the true command here. So these are the ones that sort of are worrying, and there's a lot you can do with built-in Windows commands. So process creation, we don't get it. Command line doesn't do anything, and this never hits PowerShell. So running these sorts of commands through our testing through EDR and logging, we just do not get the log whatsoever. And so what we'd be looking at, if I was an attacker of built-in tools to use, would be NetSH, but it's not even that useful because a lot of organizations just turn off the Windows firewall. CertUtil though, certificates in Windows have been a problem for about 2 years now. There is a really simple escalation from domain user to domain admin through incorrectly configured certificate templates, and almost every organization that has a CA running on Windows has at least one certificate template vulnerable to this escalation, which you'd be able to find and do most of the attack using CertUtil, and then the last few things are different attack tool. MSBuild is pretty cool. Just pass it a project file. It can compile and run inline. So it doesn't just need to compile the exe. MSBuild can run it too. And so we could completely hide what is run through MSBuild, which could be anything .NET wise. VSS admin, this will allow us to abuse volume shadow copies. Generally, this is done when attacker gets to a domain controller, but it is useful on other servers. If you've taken control of a domain controller, it's game over anyway. But you can create a shadow for C and take the NTDS file, and then you've got all the passwords for the domain, hashed of course, but yeah, you could crack them. And then reg. The amount of registry keys still in Windows that allow for a degrading of security is huge. This is a classic one we look for, wdigest. If you change this registry key, wait for a reboot, so they'd just wait for patching or reboot a server. LSAS now has plain text passwords cached in there. So despite everything Microsoft's done in the last sort of 5 to 10 years to protect LSAS specifically, this one registry key will override it. Now you do need to be local admin to write that key, but that's not extremely difficult. And you could hide it, no one would ever know. So I added in the logging locations, mostly for if anyone was to read this afterwards, but these are the group policy locations for each of these logging types. And we, for our customers within our monitoring, we do turn them all on with module logging set to star. But of course, there's always caveats. Sysmon is really good, but it is more difficult to maintain long term because you do need to install it on every endpoint, and you need to provide it with a configuration file. Which needs to be updated because each time Sysmon comes out with a new piece of functionality, you'll need to basically reinstall Sysmon with a different config file. And so across fleets of thousands of servers, that can become quite a task just to keep Sysmon up to date. And then you've got your device process events. So if you are running Defender XDR, you'll get those, but there's currently no PowerShell logging. The only way you see PowerShell is if there is PowerShell within that process tree for a detection, which is, it's common enough, but with this technique, it sometimes doesn't trigger. So then we thought EDR will be the savior. It's often the first line of defense and the last line of defense, and in the middle is where the good stuff is. Unfortunately, EDR was pretty, well, it was a hit and miss. So 50% of these are enterprise grade EDRs. They're all different. We had customers and we were able to get 6 different EDRs, and they're configured for the organizations. Most have a high level of blocking configured, but these are real world configurations, not turn absolutely everything on. These are actually usable. And so this one was the who am I encoded command. And the first 3, nothing got the file right, which I'm not surprised by. EDR's not there to detect every single file upon being written. There's just too much. Whereas what they all claim is once the executable is run, we detect the activity or what happens, which I kind of agree with. And so half of them got the execution, even just of a who am I, and we wouldn't ever get a detection if we just ran who am I. So we were pretty confident they were detecting the technique. The other 3, not a beep, and we were able to execute all day, every day on those 3. So then to make the test a bit fairer, we did the VSS admin create the volume shadow copy for all of C drive, which would be generally flagged at an information or a low. You'd want to know about it, but it's not necessarily the end of the world, and we had exactly the same set of detections. So we were pretty confident here that these 3 were detecting the technique rather than what we were executing, which is what we wanted. The technique is the thing we cared about here, although the detections all had really generic names. That doesn't matter so much with the way they work these days, but it sort of got Defender later, as we'll see. So I mentioned we had, so we have a program where we take university students who are in their last year, we take them for their final semester and they work with us on projects. I ran through this presentation with the team a few months ago, and they're called WIL students, Work Integrated Learning. One of the WIL students saw that it was run in .NET, saw that we needed the same processes, and saw that it was being detected by a number of EDRs, and they rewrote it in C over a weekend. So he's a smart kid. So the GitHub repository is up there as well. It's up to V4 now, I think, as he sort of iterates and just adds more functionality. And it's basically, it's the same technique, but it's written in C. So it's done slightly different way. The outcome was not what I expected. So now one of the EDRs got it on file right. There must be something in there. There must be a string or a function call that EDR says is just not usually in executables. So we never even got an execution on that EDR. But EDR number 2, we could execute things all day, every day. And this is really common. It's surprising how often we'll grab source code, we just compile it and run it and see what happens in EDR land, and they detect it. But if we take it and we get rid of all comments, any silly function names, then strings it and get rid of anything else we can see, it's not 0 the amount of times we bypass EDR with that. And that led to the CrowdStrike bug bounty, was us just recompiling with most comments gone. So I have no doubt EDRs are just doing a strings pass. There are certain strings that they will just say, nope, not allowed to see that in an executable. And then there is, once it executes, behaviors. But this one now, it's exactly the same encoded command, using a similar technique, just in a different language, and we bypass an EDR on a weekend's worth of work. So, not great for us being able to not detect it even more now, but a pretty cool project for someone in their last year of university. And so this is what it looked like. Command line spoofer was detected by Windows Defender XDR, and it was the Rosina malware. And that's where I sort of thought, this is a very generic detection. I don't think there's a lot to it. And I think then when we ran in VisiRun, it was different enough that Defender just didn't detect it anymore. And to this day, we can still run V2 on Defender. I just tell it not to submit it to Microsoft so we can keep running it. But yeah, it wasn't a very strong detection in the first place, and then a weekend's worth of work and we're around it. So then we thought maybe logging, we can get some fixes on the logging side. And so Mark Rasonovich, who's now one of the quite high VPs at Microsoft, he actually authored Sysmon. He coded it in the early days, and Microsoft bought the sysinternals toolset, the suite completely. And so I added him on Twitter, gave him some examples and said, could we get the process flags? Because I'm sure something as deep down as Sysmon could just tell us that the thread was started in a suspended state. And he got back to me. I was really, really, really surprised. But he said process tampering will work. And we had played with process tampering before. Unfortunately, EVIT25 is a process tampering log. And it actually doesn't work. So I spent hours trying to formulate a response that didn't make me look like a dick, saying, hey man, you're actually wrong. And so I came up with this, and it just didn't work. And then he ghosted me and never got back to me after this interaction. But we still don't have something in Sysmon or Windows where we can see that flag. And I think it would be really useful. But I've had these thoughts in the past, and I think if we got this flag, we'd see so much start suspended, because that's just usually how Windows works. You think you have a good idea, you look under the hood, and it's not a good idea on the monitoring side. So then we submitted it to MSRC. And this is what we submitted. If you've ever submitted a bug to Microsoft, you don't actually need that much. You just need to tell them exactly what it is and how to reproduce it. And I said, hey, I'm running this stuff that's 3 years old from GitHub repos and altering security logs. And I got the classic back. Does not meet MSRC's current bar for servicing, which is their way of saying nah. But they report it as valid, which I was happy with. And then they hit me with the defined security boundaries. So if you ever see on Twitter or X, whatever it's going to be called tomorrow, people, when they get rejected by Microsoft, it's almost always, it didn't cross a security boundary. I did this talk later last year, and there was a representative from Microsoft in the audience, and they came up after and asked for the case number and that, and escalated, and I still haven't heard anything back. So we'll see. I'm not sure how easy it is to actually fix for them. I'd be happy enough that we could log and detect when this technique is used. So where we're at today is EDR coverage is pretty poor, 50% and their enterprise EDRs. Log detections, it's just not there. I can't detect built-in tools whatsoever. PowerShell and composite commands, we have a thread to pull on, but still has a chance that an analyst is going to go back so far and then think it's a false positive. Attacker mistakes is going to be something that we do see, and we have seen in some of their scripts, where they'll do things that simply don't work but still produce a logging artifact. And if they try and hide PowerShell or composite commands, as we've seen, we'll still get the detections. We just may then go back and not discover the initial actual command that was run. And lucky last, a fix from Microsoft, which 2 years now, I think, when was this? This was, Feb 24. So it's a year, it's still could be there for Microsoft to fix, but I don't have a lot of hope that it will be fixed from Microsoft. So what I'll do is jump into my trusty VM all the way back in Perth. Do we get the RDP session up on the screen? Are we able to get the my screen up?
Yeah, I'm not sure where I was connected. Maybe unplug and replug the H.
Oh, it's a different, could be a different screen. Okay, cool. So don't crucify me for my IDE, I just use whatever's simplest, so it's VS Code or this. This is command line spoofer. As you can see, I have commented out various different test commands that we've done, but you can see our PowerShell bypass. We've got our run DLL32 executable in there that runs some cool stuff that we just pull from the internet. Another encoder command which is huge, and that's our curb roasting. Add mpref, and then our firewall changes. And basically all you need to do is change those, make sure they're longer than your spoofed command, compile it, and you're good to go. It'll pull out an exe. And so then what we can do is, I've just named them as all my different commands. And what I'll do is I'll just run the built-in tool one first. And so what we can do is just quickly, so I tested this just before, is, so just looking for any of the firewalls that allow remote desktop, Hacksaw, and no rules match that on our firewall. And so what we'll do now is cls_ndc built-in tools. These are the debug versions too. So realistically, attackers, you're not going to see any of this. There'll be no window, there'll be no output. I'm just outputting it so I can remember what I've done. So that then has run. For some reason, we need to press enter. And then we'll have a look now. So our rule is in there now, as expected, so it worked. And I do have this one as a local admin prompt. And so I will quickly refresh these. It's the quickest way to get at them. You can search through these using PowerShell, but the output is not really human readable. And so we can see here, command line, we have our show the rule. So that's cool. So if we work our way backwards, as I said, con host, it's all day, every day. We've actually excluded it from a customer. We're saving them a terabyte of Sentinel space every year just by carving those out. It's crazy how much, and this one, C-script, those two together, we're carving out terabyte a year savings. Yeah, there's another one. So here we go. NetSH, Teams update, register com, blah, 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 embedding. So that's me running it. There'll be one more, which is here, because NDC built-in tools calls it, but I can name this anything. Just call it WinCalc, call it whatever you want. And so if we go back one more, this should be me showing it initially. And so we can see there was me showing it, 2 logs, both attacker-controlled command line parameters basically, and then me showing the rule again. So it's just not there. It does not get logged at all. And then this comes across. And then if we go very quickly to this one, our friendly view, if I can highlight this. Sorry, we've got to do it in general. Not even friendly view shows it. There's my padding. So the padding, did it show it? Cool. Yep, so the padding's there. And then as soon as we go into the XML side, it's stripped away, even on the local host. So it's not as though it gets stripped to be sent up to a monitoring platform. It's gone completely from the details section here, even in the friendly view. It's not there. So when I stumbled across that, I knew that we're kind of stuffed for some commands because we just weren't going to get anything out of the logs. And so then what we can do is one more where we'll use run DLL, so CLS NDC 25, run DLL demo. So this is really cool. And so all it does is pop calc, but what we do here is run DLL actually executes via the built-in JavaScript interpreter, whatever I pull down using PowerShell. So you can see how this jumps around. But attackers use this because they don't want to necessarily always put files on a system. I can host a seamless intelligence test, run DLL PowerShell calc, and it just tells me what to do, which is pop calc. But it's even .NET in there. So JavaScript, .NET, it's everything. It's almost everything in Windows. And when we go and look at the logs, but it's a common way for attackers to do things. Con host. C script. So yeah, calc produces 2 logs because calc actually calls win32 calc as well. So just another quirk in Windows. But there's PowerShell calling calc. So let's say that actually had malicious commands or suspicious command line parameters, we would get that one. We then get, this would have a detection, not for execution of bypass necessarily, more for IEX. So Microsoft don't consider bypassing execution policy a security boundary, once again. It's really there to stop you breaking a server if there is an execution policy. But IEX says, execute whatever I pass into you, and all we passed in was calc, but we can pass anything. So we can see that. So the use of IEX is suspicious. Conhost. But it's really this one. This is where we would get our main detection of PowerShell specifying TLS types with an IEX from a website. So basically here, our detection would be a combination of PowerShell, HTTP or TDPS, download string, IEX, those sorts of things all on one line for a normal user. Very, very uncommon, unless you run something like ServiceNow, which just does all sorts of stuff on servers. It's all legitimate, just takes some time to fine tune it and go through what program software like that is doing. So as you can see, we get a lot of logging artifacts there, and there's our very first one. So we still don't see exactly what it did on the command line because we get this spoofed command, but everything after that, because of how that works, being a composite command, is detectable. Just makes it a little bit, you may skip past this log because it doesn't look like it's related. So more than happy to show any of those afterwards, but are there any questions related to any of that? Yep.
If I understood correctly, there was an attempt. The attempt to see the logs, like whatever comes after the process name, these can be hidden.
Mm-hmm.
Logs. But wouldn't there be any way of tracking the suspension of the process, per se?
That's the struggle for us. So if I go back into here, try and get one that is related, even this one here, we don't get that data about the thread state at all, ever in a Windows log. So there's nothing here. All it's saying basically is calc the process is being created, then 99 million times out of 100 million, it'll run what's in there. The problem is that we can change it and we just can't see it. So there's just no, even in a Sysmon log, we don't get that state, which it's, if Microsoft just did that as a fix, is gave us the state of the process when it was created, I think I could detect it far better. But I'm still never going to know what they changed it to because it's a direct memory write.
Yeah,
yep.
Yeah, but I suggest the metadata of knowing that the process is being suspended. So even that is not logged anywhere.
Nope, not at all.
Another question, I didn't manage to follow how come in some of the logs here you do see the white spaces, but then it's not stored in the XML. Like, then where are these logs stored? Why is there no EDR that follows these logs where you do see the white spaces?
Yeah, so on this view, I don't know where that's stored. I don't know. So so the EVTX files themselves are binary files too. You can't just grab an EVTX file, open it in Notepad and scroll through it. There are PowerShell commandlets, and when you interrogate the security logs with PowerShell, you get these back, you get the XML. I don't know, and even friendly's still XML, it's just, I don't know, I don't find it friendlier, to be honest. I don't think either of them are friendly, but that's what you get when you query it with PowerShell. Where this one exists, Microsoft know. Yeah, I don't know where that one is. Haven't been able to query it, yeah. Nothing else? All right, well, thank you very much for jumping in last session of the day. Hope it was a good conference.